Hi, good day. Welcome to a demonstration of TCP/IP offload engine developed by C-DAC Hyderabad. The TCP/IP offload engine, that is TOE, is a layer between the MAC and the application resting on the server machine. The MAC, DMA, and corresponding drivers are being developed at C-DAC Bangalore along with a Vertex 6 FPGA board on which the TOE developed by C-DAC Hyderabad will be programmed. As these MAC and DMA cores are not there with us, we have used node-lock MAC and DMA, which are time-limited to few minutes, provided by a vendor to achieve 10G speeds. On the commercial off-the-shelf platform, we have been successful to handle 10G speeds for UDP and 4G speeds for TCP, where speed is possibly limited because of the node-lock MAC. Right now, as MAC and DMA at C-DAC Bangalore have come up, we have given a component of TCP/IP offload engine along with the support for integration, and it is expected that it will be completed in short time. The TCP/IP offload engine has been developed and tested on Vertex 7 evaluation platform over here at C-DAC Hyderabad. Other details are as given below. Currently, 10G UDP operation is running at speeds close to 10 Gbps and the TCP achieves speeds close to 4 Gbps along with the support of jumbo frame transmission. The total memory utilized by TOE on the FPGA is close to 1250 KB. The presentation is spread out with the demo of file transfer of PDF document, followed by the showcase of speeds achieved by UDP and TCP, and finally concluding the demo of other protocols implemented like ARP and ping operation. The lab setup is described as follows. Following is the Vertex 7 evaluation board, which is connected by a PCI slot onto the server. It is powered by the ATX cable, which is powered by the server itself. A small form factor pluggable interface is provided to which the SFP cable is attached along with the standard RJ45 interface. The SFP cable is connected to a following client machine on two other SFP cage that is provided. The following systems are used to monitor the different operations of the TOE. The server is connected on the network of the following IP and SSH on the server from the monitoring systems. Let us get started by powering up the FPGA board and the server machine. Firstly, we remote log in to the server and initiate by programming the FPGA board with the desired bit file. The TCP/IP offload engine is developed using VHDL language. Further, the bit file is generated using the Xilinx reverter tool. We set up a hardware session to program the board with the desired bit file. After the FPGA is programmed, we reboot the system so as to enable the PCI configurations to take place and the board be detected by the server machine. After the server system with the FPGA board reboots, we load the driver for the PCI configurations. Currently, we are using a node-lock MAC and DMA, which is time limited by the vendor to 10 to 15 minutes. Initially, the MAC has to be configured with the TCL script, which is responsible for initializing the MAC module. Once this has been carried out, the enablement of MAC can be verified by the revision as provided. For the first presentation, the file transfer of a PDF document is shown to the TOE. Initially, we set the desired IP that we want to set to TOE. The /icon application precisely does that, and we set the IP to 192.168.3.4, which is shown here as its hexadecimal representation. The terminal on the left hand side is the client machine to which we want to connect, and the terminal on the right hand side displays the operations which will be carried out by the TCP/IP offload engine. The file after transfer will be stored in this directory of the client applications. Next, we open the GUI for TOE, TCP and UDP operations. For the following demo, the PDF file exos.pdf will be transferred, having the following size. We also open Wireshark so as to view the transfer that is taking place. We use user datagram protocol for the transfer. On the GUI, we enter the specific fields. For UDP protocol, we need to enter the source IP address, the destination IP address, the source port, destination port, and the payload length. Then we select the file that needs to be transferred. We then open the UDP file receive application on the client side. Wireshark displays the packets transferred. When the file transfer is complete, we get the size of the file as received. We are currently using time-limited node-locked MAC NDMA. For UDP, we are getting speeds up to 10 Gbps, and for TCP, we are reaching up to 4 Gbps speeds. The speeds will be increased with the integration with MAC NDMA developed by C-DAC Bangalore. Following is the PDF file which was transferred. The board has to be programmed again after 15 minutes due to the MAC and DMA limitation provided by the vendor. We select the bit file required to be programmed onto the FPGA. Once it has programmed, we reboot the system and configure the MAC as earlier. To move on to the demonstration of the speeds achieved by UDP. Wireshark displays the packets transferred. However, at 10G speeds, Wireshark hangs. Hence, a limit of capturing 10,000 packets at a time is kept. The client system is set up to receive the UDP packets from TOE, and we initiate the traffic generation of UDP packets at 10 Gbps using a TCL script which configures the traffic generation enable parameter onto the FPGA. The speed of the client where it is receiving is 1034.37 Mbps or 1 Gbps, which converts to 8.7 Gbps. The packets are captured 10,000 at a time or any other small number so as to avoid Wireshark hang. Next, we display the speeds achieved by TCP. The TCP incorrect checksum is displayed as there is offload involved and is normal. This can be avoided by switching off RX checksumming, however at the cost of speed. Wireshark is disabled and the TCP packets are transferred at a speed of 490 Mbps, which converts to 4110 Mbps. This enablement is carried out via a TCL script, which enables the generation. To conclude, other protocols of ARP and ping operation are demonstrated, which are captured by Wireshark. TOE is now set at an IP of 192.168.3.1. The client now pings to TOE, which is at 192.168.3.1. The ping request and reply packets can be seen on Wireshark. Similarly, this can be achieved by using AR ping. Thank you.